In this video, we're going to look at the 3 different ways we can draw organic compounds. The first way we can draw organic compounds is using structural diagrams. In a structural diagram, every single atom and every single bond is shown. For example, if we wanted to draw propane, C3H8, the structural diagram for propane would have 3 carbons connected by single bonds, and then 4 bonds to each carbon, so the rest of those bonds are going to be the hydrogens. So 3 hydrogens on each end carbon, and 2 hydrogens on the center carbon. For simple organic molecules, structural diagrams are quite straightforward. However, when we get into branch structures, these are very tedious to draw. A condensed structural diagram includes all of the atoms, however, the hydrogens are collapsed onto the carbon. So looking at our previous example of propane, this is the structural diagram once again. So again, all of the bonds are shown in the structural diagram. In the condensed structural diagram, the hydrogens are collapsed onto the carbons. So this carbon, this end carbon, has 3 hydrogens. And so we would write this as CH3. Our center carbon has 2 hydrogens, and so we would write this as CH2. And then our other end, the other end carbon, also has 3 hydrogens, and we would write this as CH3. This method accounts for all of the hydrogens in the structure, but is also tedious to write when you have very large molecules. The preferred method of writing organic compounds is the line structural diagram. So starting from the condensed structural diagram we drew for propane, CH3, CH2, CH3, we can represent this with just a series of lines, and the lines are going to represent our bonds. So here we're going to draw propane like this. In this diagram, so anytime the line changes, I'm putting a blue dot where there's a carbon atom. So our 3 carbon atoms are represented. The lines between them, shown here with red hash marks, those are the bonds. Hydrogens are not shown in this, but they can be implied. Every carbon requires 4 bonds. So this carbon on the end here has only 1 bond to it, and so it must have 3 hydrogens attached. This central carbon has 2 bonds already, so it must have 2 hydrogens. And our other end has only 1 bond, therefore 3 hydrogens. Line diagrams are useful when we're drawing more complex shapes. So, for example, if we were to draw this shape, this molecule would be very tedious to draw and interpret if it were drawn as a structural diagram or even as a condensed structural diagram. But as a line diagram, we can easily interpret. So we can count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 carbons. We would also be able to assign the number of hydrogens to each carbon by counting how many bonds there already are and how many bonds each one would need. So every carbon needs 4 bonds, and so hydrogens get added until you have achieved those 4 bonds. When we learn about naming, we'll look at how we can turn this structure into a name. The last thing we're going to talk about is drawing double and triple bonds within a line structure. So if we consider the molecule propene, so CH2, double bond, CH, CH3, we can represent this with a line diagram. So we draw a double bond in the appropriate location. And again, we could interpret the number of hydrogens. One important note about carbons that have a double bond. So the 2 carbons with the double bond are in red here. The shape around these carbons must be trigonal planar. So if you're drawing a line diagram and you have 2 groups off of the carbon, you must draw it as trigonal planar. If you have a triple bond, so CH and then a triple bond, CH3, we would represent this in our line diagram And so our two carbons involved in the triple bond are highlighted in red here. You'll notice that the shape around this carbon is linear. And the reason for that is there's two electron domains. So double bond, you get trigonal planar. Triple bond, you get linear.